In this video, we are going to talk about naming cycloalkanes in the IUPAC system. So on the top left, the structure you see here, you can see that we have 3 carbons, which is associated with propane, but since it's in a ring, we're going to call it cyclopropane. Top right, you can see we have 4 carbons, which normally would be butane, but now it's going to be cyclobutane because of the cyclic structure of the molecule. Bottom left, we have cycloheptane, and then we have cyclohexane. Now let's talk about some more structures. This right here is going to be, it looks a little weird the way I drew it, but this would be cycloheptane. And then if you want to draw a cyclooctane, what you could do is draw these parallel lines and then connect them. So that'd be cyclooctane. Now, let's start looking at examples where we have substituents, because that's when it's actually going to be reasonably challenging. What would you call this compound? So as you can see, we have a cyclohexane ring because we have 6 carbons in the ring, and we have one substituent. This is the methyl, so we're going to put methyl cyclohexane. And since we only have one substituent, it's automatically assumed that it's going to be on carbon 1, so you don't need to number it. But we'll get to numbering right here as we have more than one substituent on this carbon, or on this ring of carbons. So here we have 2 substituents. We once again have a cyclohexane ring because we have 6 carbons. We can count this way to make it so that the ethyl is on carbon 1, or we can count this way to make it so that the methyl is on carbon 1. In this situation, we're going to count from bottom to up so that the ethyl is on carbon 1, because ethyl starts with E, methyl starts with M. E comes first in the alphabet, so if it is possible that the numbers are the lowest, we're going to prioritize ethyl. So this is going to be 1 ethyl, and then we have the methyl on position 2, 2 methyl cyclohexane. Now, if we have 2 methyls on a cyclopentane like this, we could just count like this, and we can see that we have 1 and 3, so that's going to be 1, 3, then a dash, and then dimethyl. Since we have 2 methyls, you put the prefix di. Then we have 5 carbons in the chain, so that's cyclopentane. Now, let's say we have a chain like this, and then we have this ring. How are we going to name this one? So, you may think that we're actually going to just go with the ring as the parent chain, but we're actually going to go with the carbon chain. The reason is because the ring has 5 carbons, and this carbon chain, the straight chain alkane, when you count it, it looks like it has 7 carbons, and 7 is higher than 5. So that's the one that we're going to use as the parent chain name. The parent chain name, in this case, it has 7 carbons, is heptane. And then whenever you have a cyclic molecule as a substituent, in this case we have cycloheptane as a substituent, and we're going to write it as cyclopentyl. That's what we're going to use. And it's going to be on position 3, so we're going to just number it 3. And we made sure to count from right to left so that it could have the lowest number on this ring. So be careful whenever you have one of those chains. If it's longer than the ring, then that's going to have the parent chain name. Now let's talk about a concept that's going to be important in naming some of these structures that you'll come across in organic chemistry. Let's say I have two compounds of ring structure like this. One of them has 2 dashes, one of them has a dash and a wedge. So how do we name these? Well, the name of both of them is going to be 1, 2, because one is on 1, the other one's on 2. And then we have, it's called difluoro, since we have 2 fluorines, and we have 6 carbons in the ring, so that's cyclohexane. And I could probably write my Y a little bit better. Now the difference is that on the left side, since both of them are dashes, they're coming out of the page, which makes it a cis isomer. So this is going to be called cis 1,2-difluoro cyclohexane. And on the right, since they have different drawings, one of them is going into the page, the other one's coming out of the page, that one's going to be the trans isomer. So we're going to put trans 1,2-difluoro cyclohexane. So now try this one out. When we start counting the carbons, do we start at the carbon with the ethyl and go toward the chlorine, or do we start at the carbon on chlorine and go toward the ethyl? We're going to start at chlorine because C comes before E in the alphabet. This is called an ethyl, and this is called a chloro. It's going to be 1, 2 like that, and you can see you have 5 carbons in total, which corresponds to cycloheptane. The chloro is on carbon 1, the ethyl is on carbon 2. We're going to write the chloro first because C comes before E in the alphabet. So we're going to go 1 chloro, 2 ethyl, cyclopentane. Now what if we have a bicyclic molecule? So let me draw one for you so you can see what it looks like. So the way we're going to name these is that we're going to look at the bridgehead carbons, which are these two, and then we're going to count the carbons that are to its right side. To its right side it has 1, 2 carbons. Then we're going to count the carbons it has on its left side. It has 1 carbon. Then we're going to count the carbons that are above it, and it looks like it has 1. So the way we're going to name this is you're going to write the word bicyclo. Then you're going to open these brackets and put these numbers in descending order. So put the 2 first, and then dot 1, and then close the brackets, and you're going to count all of the carbons that are in the molecules. So you always have 2 here, you have 1 here, you have 1 here. If you add them all up, that's going to be 4. But we didn't add these ones up, so when you add it to the 2, you get 6. So 6 corresponds to hexane, so you're going to write hexane at the end here, and that's how you're going to name this compound. Let's go over another example, similar structure, so you can get some practice with this. How do you name this compound? So feel free to pause the video and try this one out. So again, we look at the bridgehead carbons, which are these 2 right here. When we go above it, we see that we have 2 carbons, that's 2. You go to its right, it has 1, 2, 3 carbons, and so we're going to write 3 here. We have 2 when we go on the left, and so to name it, we're going to put the word bicyclo, put the numbers in decreasing order within the brackets, then count the total number of carbons, which in this case is 2 plus 2 plus 3 plus these 2. That's going to give us 9, which corresponds to nonane. So for our last example, let's draw another bicyclic compound, but let's make it a little different. In this case, it's similar to the other ones, except that the number of carbons that kind of go up like this, it doesn't have that. It's 0. Just bonds directly. So go ahead and try this one out. So the bridgehead carbons are going to be these 2 right here. When we go on the right side, we have 2 carbons. When we go on the left side, we have 1, 2, 3, 4 carbons. When we go above, we have 0 carbons. So we're going to write the word bicyclo, then list the numbers out, and you do need to write the 0, so I'm going to go 4, 2, 0. And then the total number of carbons in this is going to be, it's going to be 8, so that's going to be octane. And that's how you name this compound.